Greetings of the day from Professor Komal Mehta to all future engineers and very warm welcome to Drs. Kiran and Pallavi Patel Global University. It will be honor to witness how young mind will learn, grow, discover who they are and make a difference in the world as you set out on the incredible journey that will help to shape the thinkers, workers, citizens and difference makers you are destined to be. I am very sure that you will get maximum benefit of global exposure and tremendous support at each stage of your study by team of our experienced professors for your growth. At Drs. Kiran and Pallavi Patel Global University, we are working with a vision of being a world class university with an academic architecture built around research and innovation. It gives me immense pleasure to lead Civil Engineering Department at KPGU with primary focus of empowering students with overall development. Well, starting from what is engineering, now we are moving towards latest trend and development in the field of engineering and technology. Nanotechnology is one of the fastest growing branch. Nanotechnology is an emerging science which is expected to have rapid and strong future developments. It is predicted to contribute significantly to economic growth and job creation too. So friends, let's have introduction of nanotechnology. What is nanotechnology? Is it familiar? Is it new? Let's have a look. Friends, this is nanotechnology. Sounds familiar? Don't worry, I will make it familiar. To understand what is nanotechnology, let me explain you with very simple example. This is a Rubik cubes. I am sure you must have played with it, isn't it? Now this contains total 27 cube of 1 by 1 by 1 meter size. So its surface is 3 into 3, that is 9 meters square for one surface, and we have to multiply it by 6 as it is a cube. So total 54, and volume 3 by 3 by 3, so 27. So surface by volume is 2. If you cut down this into 2 by 2 cubic, then surface is 2 into 2 into 6, so 24, and volume 2 into 2 into 2, so 8. So surface by volume ratio is 3. If you come to 1 by 1, then surface to volume ratio is 6. What I am trying to explain here, as size reduces, surface by volume ratio, that is contact area, increases. Now those who may not be very much interested in mathematics, let's understand with simpler example. What is it? Tablets broken into powder form. You know, we Indians are proud of our Ayurveda. And what is so specific in Ayurveda? Maximum time you will observe they will give you churna to take it with some liquid. What is the difference? When tablet goes inside the body, it will take some time to give reaction. But as you broke this tablet into powder form, surface area increases like anything. So when this goes inside the body, reaction will be very fast. So since ancient time in India, nanotechnology was known to these people. Here is another example where you can see beauty of nanotechnology. What is there on the screen? As you can see, this is a cloth which is made up of nano fabric. Whatever amount of water you put on it, it will not absorb, but it is allowing it to get drained off. So can you imagine if this kind of characteristics will be available for different surfaces, how much advantageous it can be? So friends, let's have introduction of nanotechnology. Research and technology development at atomic, molecular or macromolecular level in the length scale of approximately 1 to 100 nanometer range. creating and using structures, devices, and systems that have novel properties and functions because of their small size or intermediate size, ability to control or manipulate to the atomic scale. Here are examples of application of nanotechnology. Does it have application in engineering? It has application in engineering, in pharmaceutical, in medical, in agriculture, in almost every field. Some examples are quoted here. Nanotechnology have application in textile industry, in biotechnology, cosmetics and paints, agriculture and food, biomedical and drug delivery, optical engineering and communication, electronics, metallurgy, defense, security, energy storage, and there are many other fields where you will find application of nanotechnology. Now the question is it new? What you can see here, very simple picture of a flower lotus, which you and me all have seen in reality, isn't it? What happens when rain droplet come on the pellet of this particular flower? So what happens when water droplet is received on the surface of lotus is what you can see here. In this way, it will move and ultimately it will be drained off, but it will not be absorbed. So can you imagine if this type of characteristic is available in some building material, what will be the advantage? Let's have a look on it. As you can see here, this is one structure. This is made with some conventional material and normal painting is done on the outer surface. So you can see the appearance. Compared to that, for the same structure, when nano material is used for painting, you can see whenever you will see this surface, you will always get a feeling that it is just constructed. Its lifespan will increase to a great extent. So this is the power of nanotechnology. So the significance is nanometer is 1000 millionth of a meter. A red blood cell 7000 nanometer wide. That means 7 into 10 raised to 3 into 10 raised to minus 9 meter. So 10 raised to minus 6. That means 7 mu m. Water molecule 0.3 nanometer across. Nanoscience and nanotechnologies are actually not new. Polymers, which are large molecules made up of nanoscale subunit for many decades, and nanotechnologies have been used to create the tiny feature on computer chip for the past 20 years. Advances in the tools that now allow atoms and molecules to be examined and probed with great precision have enabled the expansion and development of nanoscience and nanotechnologies. Size matters, isn't it? Two pictures are shown here. In 1912, this is the way of communication. You can see how bulky it is. Compared to that, in 2012, this is the way of communication. Now even smaller than these devices are also available, which you can easily carry. So compared to this is very much easy in dealing. So these are the effects of nanotechnology. One researcher have quoted, can't we accommodate 24 volumes of encyclopedia on a tip of a pin? Now what we are talking about? A tip of a pin. It is hardly 2 mm. And we are talking about accommodating 24 volumes of encyclopedia on a tip of a pin. So it is on the research scale. But if it will be possible, you can imagine the power of nanotechnology. So friends, let's understand on meter scale actually what is nanometer. Let me make you one thing very clear. When we are dealing at normal level of size of particle, it is always law of gravity which will be applicable. But when we are dealing at atomic scale, that is at nanoscale, law of quantum physics will be applicable, law of gravity will not be applicable. Here a scale is shown which is familiar to you. You are familiar with the conversion of meter to centimeter or to millimeter. So 1 meter is 100 centimeter, it is 1000 millimeter. 1 centimeter, it is 10 raised to minus 2 meter and it is 10 mm. You are aware about it. When you come down to 10 raised to minus 3 meter, which is nothing but 1 millimeter, it is also 10 raised to 6 nanometer. Now when we come down to 10 raised to minus 4 meter, it is 0.1 mm, it is 100 mu m. Mu is 10 raised to minus 6. You are aware about it, right? So when we come to 10 raised to minus 6 meter, which is visible spectrum, it is 1000 nanometer. So 1 nanometer is 10 raised to minus 9 meter. So you can say that 1 nanometer, it is 1000 times smaller than 1 mu m. So you can see how small nano is. But it is not a new thing, right? In nature itself, there are many examples which represents nanotechnology. I have presented some over here. As you can see, ant 5 mm, dust mite 200 mu m, fly ash 10 to 20 mu m, human hair 10 to 50 mu m, red blood cell, also ATP, DNA structure, atoms of silicon, these all represents nanotechnology. Compared to this, there are also many examples which are creation of humankind which represents nanotechnology. So head of a pin size 1 to 2 mm. Also in 21st century, assemble nanoscale building block to make functional devices. For example, a photosynthetic reaction center with integral semiconductor storage. Then microelectromechanical devices, nanotube electrode, carbon nanotube, all these are examples of things which are man-made. So this one slide represents actually what is nanotechnology. On a meter scale, you can have an idea of nano size. Also here examples which are natural and man-made, they are represented to give you idea of what is nanotechnology. Now actually it is not a system or process or some new technology, but there are nanomaterials which we can use in our conventional technology so that the process output will be more efficient and speedy. So nanostructure examples like clusters and nanocrystals. So example of application is insulator, semiconductor, metal, magnetic material. Other nanoparticle, ceramic oxides, buckyballs, nanowires, metals, semiconductors, oxide, sulfide, nitride, nanotube, carbon including furnaces, etc. So actually nanomaterial have some adjustable properties. These are some specific properties which has some specific characteristics, and due to these characteristics they have application in specific field or specific process to increase the efficiency. Say for example, catalytic property, better catalytic efficiency through higher surface to volume ratio. This is mainly useful for chemical or environmental field. Electrical properties, increased electrical conductivity in ceramics and magnetic nanocomposite, increased electric resistance in metals. Magnetic properties, increased magnetic coercivity up to a critical grain size, super paramagnetic behavior. Mechanical, improved hardness and toughness of metal and alloy, ductility and superplasticity of ceramic. Optical, spectral shift of optical absorption and fluorescence properties, increased quantum efficiency of semiconductor crystal. Spherical property, increased selectivity, hollow sphere for specific drug transportation and controlled release. Biological property, increased permeability through biological barrier, improved biocompatibility. So these are some basic properties which make this nanotechnology a hero, right? So what are the basic applications in different fields of engineering. So, in the field of automobile industry, if we see, in earlier days, what was the size of two-wheeler and how heavy and bulky main stand was? Compared to that today, two-wheelers are having flexible stand which any teenager can also easily operate. Compared to painting or outer coating of car of different segments in earlier days, nowadays if you see latest higher segment car, it has a specific type of painting which will not allow any dust or water particle to stick on it. So these all are the advantages of nanotechnology. So it gives you lightweight construction, painting, catalyst, filler, sensor, coating for windscreen and car body, etc. In chemical industry, filler for paint system, coating system, switchable adhesive, magnetic fluid, these all are also applicable for environmental industry. In mechanical engineering, if we see wear protection for tools and machines, lubricant free bearing, and there are many other examples in mechanical engineering. For electronic industry or for computer engineering, if we see, what was the size of computer, your PC, before 10 years? And what is the size of your laptop nowadays, right? As you progress towards the time, you can say, from earlier 10 years to today, for everything, your size has reduced and efficiency has increased. So this is the effect of nanotechnology. Even in electronic industry, data memory, display, laser diode, glass fiber, optical switches, conductive anti-static coating, etc. In civil engineering, in each and every building component, you can have effect of nanotechnology which increases sustainability of a building, which increases the eco-friendly solutions. So, in civil field, if you see, construction material, thermal insulation, flame retardant, surface functionalized building material, facade coating, groove mortar, and there are many other examples. It also have applications in medicine field like drug delivery system, active agent, contrast medium, medical rapid test, antimicrobial agent and coating, agent in cancer therapy, etc. And there are many other applications in each and every field. Some examples are quoted over here. So nanotechnology and environment have potential benefit and sustainability effect. Nanotechnological product, processes and applications are expected to contribute significantly to environmental and climate protection by saving raw material, energy and water, and by reducing greenhouse gases and hazardous waste. Now when we use it has some potential environmental benefit. Rising prices for raw material and energy coupled with increasingly environmental awareness of consumers are responsible for a flood of product on the market which promises environmental protection. But whether testing is done before putting it in the market is question mark. Nanomaterial exhibit special physical and chemical properties that make them interesting for novel environmentally friendly product. Examples include to increase durability of material against mechanical stress and weathering, to increase the useful life of a product, to reduce cleaning efforts by nanotechnology based dirt and water resistant coating, to improve the energy efficiency of building by novel insulation material, to reduce weight and save energy during transport, adding nanomaterial to nanoparticles to a material. So nano-engineered materials such as nano-adsorbent, nanometal, nanomembrane, photocatalyst, or there are many other varieties. They offer the potential for novel water technologies that can be easily adapted to customer specific application, because this is one of the application which affects our day-to-day life. One of the most important advantages of nanomaterials when compared with conventional water technology is their ability to integrate various properties resulting in multifunctional system such as nanocomposite membranes that enable both particle retention and elimination of contaminant. Further, nanomaterial enable higher process efficiency due to their unique characteristics such as high reaction rate. So friends, nano can reach to a point where our imagination ends. So this is the power of nanotechnology. In this presentation, very basic knowledge of actually what is nanotechnology is included, but those students who are interested in digging more, they can definitely contact me professionally through LinkedIn. Researchers can contact me through ResearchGate, and I am always available in KPGU campus. Thank you.